Dear learner, I am happy to meet you today again on this same platform. I hope you've already subscribed to my channel. If you have not done so, please do that for me. I hope you have ever met a question like this on your screen in your exam and you did not know what to do. Today, that is what we are going to do. And after the lesson, I hope you may understand, and it will be very easy for you to solve questions such as this in exam. Today, under plane geometry 2 or circle theorems, we would like to look at angles subtended on the diameter at the circumference of a circle. Stay tuned, and I hope you may enjoy this lesson. We already know that the angle formed at the center of a circle is twice the size of the angle at the circumference, subtended by the same chord or arc. And though we know that, let me prove to you again. Good. Moving angle EJD and placing it on angle EID, we see that it covers half of it, and therefore we have these properties saying that angle EID is equal to 2 times the angle at the circumference, and the vice versa is the second point, which says that the angle at the center, when we take half of it, or when we divide it by 2, we get the angle at the circumference, and that is the second point. For today, as I have already told you, we are going to explore, and we may know the reason why questions such as the one I introduced to you exist. Now, I am going to move the edges or the base of the diagram inside the circle, and let's look at what happens whilst I move the edges E and D. Okay, I hope you are observing this quite well. Good. I hope you are observing. You are observing. Good. When it reaches the diameter of the circle, the edges EI and ID become straight and therefore forms a straight line. And we see the angle that is formed on the straight line. So we are going to move angle EJD and place it on the angle on the straight line. And let's see what happens. Observe it well and write down your observation. Good. We can see that, like before, the angle at the circumference EJD occupies exactly half of the angle on the straight line ED. And we know that angle on a straight line add up to 180. So taking half of it would give us 90 degrees. This means that the angle EJD, or the angle at the circumference, is 90 degrees, and that is shown in the point 3. That angle EJD is equal to half of 180 degrees, because the angle formed here is on the straight line ED, and that is 180 degrees. When we take half of it, we get 90. So this angle you see here, EJD, the angle at the circumference, is 90 degrees. Let me take it back. So the property guiding this theorem states that angles subtended at the circumference by the diameter is right angle, that is 90 degrees, and that has already been shown. It has been proven. Let me go back and show it again. I am going to move angle EJD and place it on angle EID, the angle on the straight line. So look at it well, observe it. That is it. And it covers half of it. That's why it is 90 degrees. Let me take it back and move the angle at the circumference for you to see what happens. Okay, this one looks familiar. Let me move angle EJD and place it on the angle at the center here, and let's see what happens. I hope you are observing that too. Good. It still covers half of the angle at the center. Let me take it back and move it in the other direction, and let's see what happens too. Okay, this too looks familiar. So let me move it. Okay, and you see that it still covers half of the angle at the center. And therefore, it shows that wherever I place it, provided it is placed on the circumference of the circle, it could even be down here, and there should be a diameter. When there is a diameter, then we can say that the angle at the circumference is 90 degrees. And let me move the angle back to its main position. Let us draw a line from J to I, the center. You can see that we have two triangles. Don't forget that these triangles, each of them has equal base angles. Don't forget that at all. So for triangle EIJ, the base angles here are all equal. And for triangle JID, the base angles here are also equal. Now look at what we are going to do. I am going to move the angles at the base and look at what happens. I hope you observe that. Good. We can see that these two base angles cover angle EJD, the angle at the circumference, and it fits equally when the two angles are put there. It shows that when we add these two angles at the base, JED and EDG, they must add up to 90. So we have this angle EJD is equal to the sum of these two angles. Angle DEJ and angle EDG. So when these two angles are added together as they are in point 4, they must give you the angle at the circumference. And we already know that the angle at the circumference is 90 degrees, which means that when we add the two base angles, they should give us 90 degrees, and that is in point 5. 90 degrees is equal to angle DEJ plus angle EDG. So that is what I have for you today, but I don't want to end here. I want to go back and move the angle at the circumference, and let's see what happens. Let me move the base angles and place them on the angle at the circumference. Good. That one fits well. And let's see the other one too. Good. So you see, when we add them, they should give us 90 degrees. This means that when we know angle JED and we know angle JDE, when we add them, it should give us the angle at the circumference. And even with this, there is no need to add because you already know that the angle at the circumference is 90 degrees. But assuming you know only one of them, then it must be easy to find the other angle, because knowing that these two angles, these two base angles added together may give you 90 degrees. If we know this to be 40, it tells you that this angle is also 50 degrees. There is no need for you to go and add everything in the triangle or one of them and tell us the value of the other angle. Let's move them back and let's move the angle at the circumference to the other side, and let's see if it also works. I am moving the angles. I am moving them. Beautiful. So it doesn't matter wherever I place the one at the circumference. Now let's go and solve questions. so that we may understand this theorem very well. Question 1. In the diagram below, O is the center of the circle. If angle RPQ is equal to 30 degrees and angle PRQ is equal to D degrees, find the value of angle D degrees. So let us all solve it together. From the property and from the illustrations made by using GeoGebra, the base angles should add up to 90 degrees. So we add them. 30 degrees plus D degrees equals 90 degrees. Then we have to group like terms in order to find D degrees. And that is not done by magic. 30 degrees here should be taken to the other side of the equation. And to do that, we add its additive inverse. And the additive inverse of 30 degrees is negative 30 degrees. That's why we subtract 30 degrees from both sides of the equation. This makes this side 30 degrees minus 30 degrees to be 0, and D degrees would be left when we simplify, so that we get D degrees is equal to 90 degrees minus 30 degrees. And here what you usually say, that this should cross the equal sign so that it becomes negative, remains here. So that when the 30 degrees crosses the equal sign, it becomes 90 degrees minus 30 degrees, as you usually say. And when that is also simplified, we get D degrees is equal to 60 degrees, because 90 degrees minus 30 degrees would give us 60 degrees. Now, this is one of the shortest way of solving such a question. But let us look at the second method or the second solution, so that you pick what best suits you. So for the solution 2, we know that the sum of interior angles of a triangle should give us 180 degrees. And so from this circle, the triangle within this circle and at the semicircle, when we add angle RPQ to angle PQR and then to angle PRQ, they should give us 180 degrees, as you see on the screen. So we substitute values. Angle RPQ is equal to 30 degrees, so that is being substituted. Angle PQR is equal to 90 degrees, that is the angle at the circumference, which we already know that is 90 degrees, plus angle PRQ, and that is D degrees. When we add all these, we equate it to 180 degrees. And then we simplify. 30 degrees plus 90 degrees would give us 120 degrees plus d equal to 180 degrees. Now what we must do is to group like terms. So 120 degrees here must be at the right hand side of the equation, and that is done not by magic, but we subtract 120 degrees from both sides, and that would be 120 degrees minus 120 degrees plus d degrees equal to 180 degrees minus 120 degrees. And for 120 degrees being subtracted from 120 degrees would give us 0, making only d degrees to stand at the left hand side of the equation when simplified, so that we get 180 degrees minus 120 degrees at the right hand side. And when that is also simplified, we get d degrees is equal to 60 degrees, and that is the same as the answer we had in our first solution. But you could see that this is a little bit longer than that of the first method or solution. So what you think is best for you, you do that. Let us see our second question. In the diagram below, O is the center of the circle. If Q S R is equal to 2y plus 30 degrees and R Q S is y degrees, find the value of y degrees. And I hope you could do this. With this, we could apply any of the two methods and it would work well for us. But I am using the first method, and when that is done, you use the second method to prove that they should all give us the same answer. So let's do that. Solution 1. Angle Q is R plus angle R Q S should give us 90 degrees. So we add the base angles and equate to 90 degrees by substitution. We get bracket open 2y plus 30 bracket close degrees plus y degrees equal to 90 degrees. And we expand so that we get bracket open 2y bracket close degrees plus 30 degrees plus y degrees equal to 90 degrees. And when we simplify this, the 2y degrees, the bracket open 2y bracket close degrees plus y degrees would give us bracket open 3y bracket close degrees plus 30 degrees and is equal to 90 degrees. Then we group like terms. So which means that this 30 degrees here must be moved to the right hand side. It means that the 30 degrees here must be taken to the right hand side of the equation by subtracting 30 degrees from both sides of the equation, so that we have bracket open 3y bracket close degrees plus 30 degrees minus 30 degrees, and this would be 0, 0 equal to 90 degrees minus 30 degrees, so that when we simplify, we get bracket open 3y bracket close degrees is equal to 90 degrees minus 30 degrees. And when we simplify that one too, we get 3 degrees y degrees is equal to 60 degrees, so that we divide through by 3 degrees to get our y degrees. And when that one is done, 3 degrees would go into 3 degrees y degrees, and 60 degrees divided by 3 degrees would give us 20 degrees. So we have y degrees is equal to 20 degrees as our final answer. So I am not going to do that of the second method. You have to do it now so as to find out if that would also give us 20 degrees. So straight away, let's move on to our assignment whilst you do the second method. In the diagram below, O is the center of the circle. Find the value of angle S degrees in this. Pause the video, solve it. When we look at the strokes on the two sides, it shows that the base angles are equal because they depict that those lengths are equal. So when you compare your answer to that of mine and you get S degrees is equal to 45 degrees, it means you are correct. May God be with you till we meet again on this same platform. Bye.